So, hey everyone. I'm going to be going over a small tool we made as a part of a project course called Seng 371 today. And basically what we did in that course, or at least my group, is we created a tool to answer some kind of question. So you can find all the details out about what we did on our GitHub page. I'll post the link to that in the description of this video so you can find it. In there you'll find a summary of our results, our main question, our methodologies and how we did everything, along with how to actually download the tool. To save you all some time, right now this tool is only available for Linux. That's just what it was built for, and there hasn't been any desire for any other operating systems. If you would like it for another operating system, let us know. I'm sure we'd be happy to make it. But for now, Linux seems to just be good enough. Anywho, so to give you a brief summary of what the tool actually does is it just goes through Jira repositories and parses all the features. Based off of all the major features, I should say, we gather the data of how much time it takes to actually complete features on average from the start of the project to the end. So you'll see the average as you go along to see whether you're speeding up, slowing down, how things are going. And you can also see your estimation times as a ratio of when you plan to get something done and when you actually got it done to see how on schedule you are. We group these things together, this data together, through the type of methodology that the project implements. Methodology being is the project waterfall, agile, open source agile, whatever the project happens to be, just so you can see some kind of correlation with the actual projects themselves. Anywho, I'm going to go into how to actually use the tool now. Okay, so once you've got the tool by following the steps on our GitHub page, go ahead and launch that. I'm just going to use the original tool I built through my builds from Qt. So go ahead and launch that, and we will get our main window here, which is pretty small and pretty simple. Before diving in further, I'm going to make a small text file here. I'll delete this one and just recreate it, and I'll explain that. So each time we parse and we get the data from the projects themselves and all the features, and we calculate all the values we're going to graph, we store it in a JSON format in a text file. If you want to look at one project and then you want to compare it to another one and maybe even another and keep going on as much as you want, you're going to need all that information in one file so we can read from it. Or at least that's how it's implemented at the moment. So with that being said, let's go ahead and get our information from the first project. So as we can see, this needs a server to connect to. So we're going to pass it our server for our first project that we want to look at, which is SonarQube. And we're going to hit the connect button. Once we connect, we're going to have a set of parameters we're going to have to fill in. So through this dialog box, we have a project key, a graph, a methodology, and the file we want to write to. So we've kind of talked about all these parameters already, but let's go through them one by one just for clarity. So we have this SonarQube project, and the project key is called Sonar. So that's what we're actually looking for. Just like this activity has an act key, the SonarQube one has a Sonar key. So we can see the act key at the top here. They're all in alphabetical order, so we could scroll down, or you could just type in Sonar and find it, hit enter, and see that our keys line up. So this is the project I want to look at. Next, we want our graph type. A bar chart is not going to be too nice to look at when it's just one project. It might be a little more useful when you have more than one type of project. Otherwise, we're just going to see this big rectangle, and it's not going to be that useful. So for the purposes of this demo, I'll go over both. I'm going to go over a line graph first so we can break down what that means for one project. And due to our own research, we found out that this project was open source agile. If you want to find those things out, you can look at their wikis, you could look it up, you could contact them. There's a couple different ways of doing it. Email seems to be one of the most effective. So go ahead and locate that file that you created earlier on. And mine says text.json. You could just actually create another file, so like file.json as well, and it'll pass in this file. Even though this doesn't exist, the script should create it. But for now, we're just going to go with this text.json we just created. And then we're going to hit OK. So this might take a bit of time because the Sonar project has a lot of values. It's been around a long time. And we'll be able to see that in a little bit. Actually, we can see that they've been updating since today at 9:14 a.m. So yeah, they've still been updating stuff, and they've been around for quite a couple of years already, so that's why this is going to take a while. The reason that this little window is turning black here is because Linux thinks it timed out or isn't really responding correctly, and we have to wait for the graph to pop up. So that's going to be it. This window actually has no functionality until that graph's closed. So it's going to hang on there due to the fact that it's not multi-threaded. But for now, we're just going to wait till it pops up, and then we can see our values. While we're waiting, the next thing we're going to take a look at is another project, particularly DSpace, which we know is an open source one. And then we're going to use the bar chart next to be able to determine the differences between the two methodologies with respect to one project each. All right, so here is our data. What does it mean? On the x-axis, we have time elapsed into project in days. Overall, we can see since the beginning of this project, which is marked with 0, to the end of this project, which is about 2,685 days, there's been that's where we have our data. On the y-axis, we have average feature time in days. That just means all the issues that we have in Jira and the time that we completed them. That's kind of what we're basing this on. So this is the first issue that was ever completed. That doesn't mean that that's issue 1 or feature 1. That's just the first one that's completed. So if I start feature 1 and finish it somewhere, say here, that's where it's going to pop up, where this is just the first guy that's finished. So based off of everything we finish over time, we're going to get some average value, which looks like it's around this top line here, of how quickly we're completing things. This data is pretty cool. You can see how fast and slow you're completing things at times. However, it'd be more useful to get some relative information, which is what we're going to do next. So let's go ahead and quit this application and start up another one. So we're going to restart the application and run it. Same thing we basically just did, but for a new project. So here's the server I'm going to be taking a look at, and we're just going to go ahead and connect to it. And remember, as I mentioned, we're looking at DSpace, which has a project key of DS. So that's going to be important to remember when we're looking at our project itself. So here we go, project key DS right here. We want to bar chart this time because we want to compare it to the old information that we had from Sonar. Now we're going to take a look at the open source aspect of this project. I mentioned it was open source earlier. If you're curious on how we found that out, we just looked through their wikis and gave them possibly an email. That's how we've been doing all of them so far. And it's very important that you use the same text file because it'll have the information we just calculated. So hopefully all of that made sense. We picked our project. We then chose that we wanted a bar chart to show. And then we just chose the methodology and the text file that we wanted to write and read from. So after we execute it, we play the waiting game again. If the main window happens to close, the project crashed and something went wrong. But as if it just turning black, don't worry about that. Probably an easier way to show that something's going on later on in the future. But for now, it's that's just how it acts when this graph's waiting. So as soon as I close this, this would regain its color, so it is acting correctly. Let's go ahead and expand this window and break down what we're looking at again. So we have this open source agile label, and we have this open source label. If you can remember, the Sonar project had this open source agile label we put on it, and the DS project had this open source label we put on it. So what these values are every due date we took a look at and the completion time we had divided by each other. So if we have a 1-to-1 ratio, the value is 1, that means that we completed every issue for when it was planned. So we planned to complete it maybe September 10th, it was done on September 10th. If we gave a project 10 days to complete it, and we completed it in 14 days, and we only had that one issue, we would get a value of 1.4, meaning that we just took 1.4 amount times the time that we expected. In this case, it's 1.4 on average. So 1.4 on average isn't too bad. And this is kind of what we would expect from seeing an open source project with no deadlines. We finished things in 4.4 times the amount of time, which is pretty massive. So we can see that from these kind of conclusions, at least on a bigger scale, say we looked at a lot more projects, and if we still had these kind of things, we could come to the analytical conclusion that maybe an open source agile kind of approach to things might be a bit quicker than an open source if you're following some kind of tight schedule. Anyways, that's a quick overview on how to actually use the project. For more information on it, just visit our GitHub page posted in the description below, and we can go over our methodologies, how we did things, how you can download the tool, and what our results were. Anyways, thanks for watching.